When it comes to dividing monomials, the easiest way to do that is to think of them in terms of a fraction. And especially if you think of them in the beginning as a fraction in expanded form, it's really easy to see how you're going to go about simplifying this. So 12a to the fifth, if we expand it, can look like this. 12 times a, 5 times, and 6 times a, 3 times, and we write it as a fraction. Now when it comes to simplifying fractions, we know that any time we have a numerator and a denominator that share a common factor, we can divide that factor out. So if we look at this, 12 and 6 have a common factor of 6. So we can divide each of these numbers by 6. 12 divided by 6 gives me 2. 6 divided by 6 gives me 1. The next thing I want to do is look at my variables. And again, anything that has a common factor can be divided out. So I know that any time I have an a that's in my numerator and an a that's in my denominator, they can both be divided and will cancel out and give me 1s. So all of these a's, these 3 a's on the top and these 3 a's at the bottom, are going to cancel out and be simplified technically to be 1s. In order to come up with your final answer then, all you have to do is look at what you're left with on top. And when I look at the top of this fraction, I see that I still have a 2 and I still have 2 a's. So that means my numerator for this is going to be 2a squared. And then I want to look at what I have left on the bottom, and when I look at this, everything on my bottom is a 1. So technically my denominator is a 1. Now we know anytime we have a denominator of 1, we don't really need to write it that way. So the final answer for this problem would be 2a squared. Now we can apply these same rules to problems that get a little more complicated. And again, if you want to expand them out, they're pretty easy to solve. Okay, let's look at this top part here. I'm going to have 18. I have 5 x's, 1, 2, 3, 4, 5 x's on the top, and I'm going to have 4 y's on the top, 1, 2, 3, 4. All of that is over 24, and 8 x's on the bottom, 1, 2, 3, 4, 5, 6, 7, 8, and 2 y's on the top, on the bottom, 1, 2. Again, it's time to start thinking of this in terms of fractions. What do we know? Well, we know that 18 and 24 both have a common factor of 6. 18 divided by 6 gives me 3. 24 divided by 6 gives me 4. So that means when I think about my final answer, I'm going to have a 3 on the top and a 4 on the bottom because it can't be simplified any more than that. Next, I want to look and see if there are any variables that I can cancel out. If I look, I can match up my x's for my numerator and my denominator and cancel them out 1 to 1. And when I do that, I can see that I'm left with 3 x's down here on the bottom. So I'm going to make sure I have 3 x's on the bottom. That's x cubed on the bottom. My last step is going to be to see if I have any y values that can cancel out. And when I do, I see that I have 2 y's on the top and 2 y's on the bottom. Both those can cancel out. And again, I see I'm left right up here with 2 y's on the top. So I make sure that I have 2 y's on the top, and that would be my final answer, 3y squared over 4x cubed. Now, if you want to get away from expanding it, we do have another option. And that option is we can still divide our numbers just as we have been. Okay, so I know negative 15 and 3 have a common factor of 3, so I can simplify those just like I would normally. But instead of drawing this all out so I have all of my a's on the top and all of my a's on the bottom, I can apply my exponent rule. And my rule says that, this is our quotient rule if you remember, the quotient rule says when you divide 2 bases that are the same, you subtract your exponents. So what I want to do now is think about subtracting these exponents. But because we know, like if you look at this problem to the left, sometimes I'm going to have variables that are left up on the top. Sometimes I'm going to have variables left on the top, and sometimes I'm going to have variables left on the bottom, depending on where they started out with more. When I use just my subtraction rule, I have to think about where are my leftovers going to be. Okay? So in this case, if I'm looking at a squared, I'm trying to highlight things for you. If I'm looking at a squared here and a to the 7th, my rule says what I want to do is subtract those exponents. Well, 2 and 7, if I subtract them, that's a difference of 5. Okay? So if I think about that, that means I'm going to have 5 a's left over. What I need to think about is where are those 5 a's? Okay? Again, if we think expanded form, I have 2 on the top and 7 on the bottom. If I cross them out, where are all my leftovers? Well, they're all down here on the bottom. So technically, when I subtract them, 2 and 7, when I subtract them, I'm left over with a difference of 5. Those 5 A's are going to be located on the bottom here. I can do the same thing now with my B's. Again, think in your head, I've got 1 on top, I've got 3 on the bottom. When I subtract them, that's a difference of 2. But where are the 2 left over? The 2 are left over on the bottom. So when I write my B to the second, I'm going to make sure it ends up on the bottom. Now, sometimes following rules are a little bit tricky because they get confusing, but it definitely will still give you the same answer as long as you do it correctly. And as always, we know this 1 here is extra. We don't really need it, so if you want to write your final answer, you could simplify it and just have -5 a to the 5th over b to the 2nd. Now, there's one last thing we need to think about, and that is negative exponents. You are not allowed to do these problems and have negative exponents. Sometimes they'll be given to you. Like if we look right here, we see we have a negative exponent. Or down here, we have a negative exponent. And in a problem, that's okay, but when you write a final answer, you're not allowed to have negative exponents. So the easiest way to deal with a negative exponent is to make it positive. And the way you make a negative exponent positive is that to make a negative exponent positive, you move the base and the exponent to the opposite side of the fraction. That will make the power positive. So essentially what that's saying is, by me taking this a to the -4 and moving it down here to the bottom, what's going to happen is that's going to end up being a +4. And I can take this c to the -3 and move it up here, and when I move it up top, it becomes positive. Now, everything else in this fraction is going to stay the same. My -3 here is going to stay the same. My b squared is going to stay the same. On the bottom, I still have 21. I still have an a squared. I still have a b squared. Okay, the only thing that changes is the 2 things that I had to move. Now, let's simplify this just a little bit here. Okay, so if I think about it, I've got -3 b squared c to the 3rd up on the top. But what I did here is I moved one of these a's down here to the bottom, so that actually gives me 2 groups of a that I'm going to put together. If I have a squared and a to the 4th, that means I have 6 a's total down there on the bottom and 2 b's. So let's take some time and actually simplify this problem now. I know that -3 and -3 and +21 have a common factor of -3. -3 divided by -3 is going to give me 1. -21 divided by -3 is going to give me -7. Okay? I have 6 a's on the bottom. I don't have any on the top, so there's nothing there to subtract. I know that I have 2 b's on the top and 2 b's on the bottom. If I think about that in terms of expanded form, both of those are going to cancel out. Okay? If I subtract them, b to the 2nd minus b to the 2nd is b to the 0, which is the same as 1. And then I still have my c's on top. So my final answer to this, if I look at what I have left on the top, I have c to the 3rd, and on the bottom I have -7 a to the 6th.